In this media, we are going to discuss about the phosphate. So why we are adding this phosphate in the boiler water, that is feed water, and why we are maintaining a level of certain level of phosphate. This is very important and it was asked by the surveyor in MA class 2. So see, basically calcium phosphate is virtually insoluble in boiler water. Even small levels of phosphate can be maintained to ensure the precipitation of calcium phosphate in the bulk boiler water away from heating surfaces. Therefore, the introduction of phosphate treatment eliminated the problem of calcium carbonate scale. See, basically the scaling and corrosion. See, phosphate is anti-scaling and anti-corrosive. Okay, when calcium phosphate is formed in boiler water of sufficient alkalinity, okay, so alkalinity here is important, that is pH 11 to 12, a particle with a relatively non-adherent surface charge is produced. This does not prevent the development of deposit accumulation over time, but the deposit can be controlled reasonably well by blowdown. So we are doing this blowdown to reasonably to blow it. In phosphate precipitation treatment program, the magnesium portion of the hardness contamination is precipitated preferentially as magnesium silicate. If silica is not present, the magnesium will precipitate as magnesium hydroxide. If insufficient boiler water alkalinity is being maintained, magnesium can combine with phosphate. Magnesium phosphate has a surface charge that can cause it to adhere to tube surfaces and then collect other solids. For this reason, alkalinity is an important part of phosphate precipitation program. The magnesium silicate formed in a precipitating program is not particularly adherent. However, it contributes to deposits buildup on a part with other contaminants. Okay, so we are doing this phosphate in boiler waters. So phosphate are required to with carbonates of magnesium and calcium for permanent hardness salt to form sludge. So they are forming the sludge as compared to if there is no availability of phosphate, then what is happening is that because of chemicals that we are adding on the tubes, they stick and form what is known as scale. So scale is a very dangerous, because that will certainly over a period of time that will reduce the efficiency of your boiler, because the heat transfer, heat transfer getting reduced, and heat is very significant in boiler, so it promotes sludge formation rather than scale formation. So it has a reserve of 20 to 40 ppm that we are supposed to maintain. The phosphate, sodium phosphate react with any calcium salt present in the boiler water to form calcium phosphate, which becomes a non-adherent sludge and can be removed by boiler blowdown. So we are doing this boiler blowdown. See, everything about boiler, what are the alarms, trips, boiler water treatment, how we do, what all chemicals we eat, oxygen scavengers, everything about boiler is available in the video. Okay, you can search there. Already I have covered long back. So if no phosphate reserve, the calcium salts, that is hydroxide of calcium, will keep on adhering to the boiler tube, reducing heat transfer. So what is happening is that if there is no phosphate, then this calcium salts, okay, or the hydroxide of calcium, okay, or the carbonate, that what is happening is that they keep on adhering to the boiler tube, and slowly a time will come when there will not be any heat transfer because of the scale formation. So this is very dangerous situation. And if you are adding sodium carbonate to maintain alkalinity, then the sodium present in the salt react with hydroxide, which later on cause caustic cracking. So this is another problem that is happening, because if you are adding sodium carbonate to maintain the alkalinity, because there is an alkalinity range of the boiler that has to be maintained, then the sodium present in the salt react with hydroxide. So this sodium which is present, that will react with the hydroxide, which later on cause caustic cracking. Hence it is recommended to use phosphate based salt instead of carbonate to maintain alkalinity in boiler. So what is preferred and what is done is that what is recommended is that to use phosphate based salt instead of carbonates. So we are not supposed to use CaCO3, that is calcium carbonates, or any carbonate based salts. Rather than what we are supposed to use is phosphate based salts. Okay, so phosphates are acting as a scale inhibitor as well as corrosion preventer. As I already said in the beginning, that phosphate why we are using, because it is anti-scaling. Two things you keep in mind: anti-scaling and anti-corrosive. Also, too high phosphate causes excess froth formation. Now see, everything has to be in a certain limit. You cannot be adding continuously the phosphate again and again. So what is happening? So if you are supposed to add phosphate continuously, then what is happening, in after a certain interval, the froth formation takes place. Now this froth is also very dangerous situation, forming in boiler, which also reduces heat transfer capability. So it is reducing heat transfer capability, contributes to scale formation and increase boiler alkalinity. So it is contributing to scale formation and increasing boiler alkalinity. Phosphate buffers the boiler water, reducing the chances of large pH swings due to development of caustic concentration. So 11 to 12, that pH that we already discussed and covered, that is important. So what we have seen, we'll just go through in a nutshell, that advantages of phosphates in boiler water treatment: easy to detect and control, low requirements for the purity of feed water, can be used under high pressure, easier to be accepted, residual phosphorus is not corrosive, maintain a high level of orthophorus, can act quickly when the hardness of the system leaks, and lower cost. Obviously, cost is important factor for anything that we are discussing. So what is why we are maintaining a phosphate in the boiler? Because of it is anti scaling and anti-corrosive. It forms sludge rather than forming scale, and sludge we are always doing blow down of the boiler water, so this can reduce the sludge amount as well. So these are the important points that we are supposed to tell to the surveyor, then your answer will be accepted. Okay, thank you so much.